Okay, so this is the 1-1 Algebra 1 notes. We're going to look at solving equations. We're looking at TEK 5A, where you're solving linear equations in one variable. Definition that you need to know and write down is an equation is a mathematical sentence that uses the equal sign to show two expressions are equivalent. So there are two methods that you can use when you're doing one-step problems. The first one is guess and check method. And in this case, what you're going to do is you're going to say, well, what seems to be, if I take 6 away, would be close to 4. So I'm going to guess 11, and I'm going to test that. Well, 11 minus 6 is 5, so 11 is not the solution. So I'll go one more down to 10 and try it. 10 minus 6 is 4. This can work really well to get you in the ballpark area, but it does not work really well if the equations are two-step. The other way you can do it is called using the working backwards, and that's where you're thinking, what plus 6 is 10? Well, what can I add to 6 to get 10? Well, if I know that I can take 10 and subtract 6, I'll find out my answer. So is 10 minus 6, it gives us 4, and then we check it to say, is 4 plus 6 10? And that is. Okay, so when we're doing this, we want to find a solution of an equation, which is a value for the variable that makes the equation true. So there are four properties that we use, but there is something you need to note. If you do any of these properties to one side of the equation, you must do that to the other side of the equation. Please write that down. It is the most important thing with algebra. Everything on algebra is basically a mirror image. Everything that you do to one side must be done to the other. So the first one is addition property, and that just simply says that when you you have to add the same number to both sides. So if you have number 3 on both sides of an equal sign, but you want to add 2 to one side, you must do it to the other side. If A and B are the same number, they represent the same number, and you want to add C to one side of it, you have to add C to the other side. So this is the elementary version of what you would have been doing, and now we're just changing it to variables to represent all numbers that this applies to. So this is like a example of when this would be true. And this is true for all worlds. Okay. The next one is subtraction. Subtraction property says that if you subtract one number from one side, you have to subtract the same number to the other side. So if you have 7 on both sides of the equal sign and you subtract 5 from one side, you must do it to the other side to get the same answer. If A and B are the same number and you subtract C from one side, you must subtract C from the other side. The third one is the multiplication property, and that says you multiply both sides by the same number. So if 3 is on both sides, you multiply by 4 on one side, you must do by 4 on the other side. If A is the same number as B and you multiply A by C, then you must multiply B by C. And the division property is the same. You want to divide both sides by the same number. So 15 is equal to 15. We want to divide by 3 on one side. We must divide by 3 on the other side. Now, there is a caveat to the division property, and that is you may not divide by 0. So if this situation is something where you would have to divide by 0, then this is an undefined problem, and there is no solution. Okay, so here is the third way to do it is by solving the equation by using the properties. And we're going to do our work this way, where you'll show your work of what you're doing and tell y on the other side. So your first one is 3x minus 2 equals 6. I see a minus sign, so I'm going to do the opposite of that minus sign to move it across the equal sign, and that's the addition property. And then that gives us the 3x on one side and 6 plus 2 is 8 on the other side. Then I see 3x, which means 3 times x. There's an imaginary times sign there. Opposite of times is divide. So divide by 3. 3 divided by 3 goes away, becomes 1, and we get x. 8 divided by 3 becomes 8/3. So we're due to the division property. Now we want to check our work, but we want to put our answer we think it is back in the original equation. Nothing we've done in between. Always go back to the very original equation. Okay? So 3 times 8 over 3 minus 2, we want to know, is that equal to 6? We don't know for sure. 3 divided by 3 is 1, so 8 times 1 is 8. That's where 8 came from. 8 minus 2 is 6. 6 is equal to 6. That works. Okay, so this is a question that has a fraction in it. I want to remind you that 1/2 z is the same thing as z divided by 2. They mean the same thing. So if it works better for you to rewrite your equations where you have the z divided by 2 instead of a fraction there, that is perfectly fine. Just be careful that your end result looks the same. So if you had a situation where it was like 2/3 r, you would want to write that as 2r over 3. So all the numbers have to stay. You just can write it over as one fraction. Okay? So that's something completely separate. All right, so we're going to do our work. I see a plus sign, so I'm going to do the opposite of plus, which is subtract to get rid of the 4, and that moves it over here on the other side to make that 6. And then opposite of multiplication, there's multiplication there, is normally division, but since 1/2 z is really z divided by 2, that's really division problem, so that's why we're multiplying. So multiplying 2 times divided by 2 gives us z, and then 6 times 2 gives us 12. Now we want to check it. If you had made a mistake on this area, the checking will catch it. Will help you to find where you made an error. So put it back in the original equation, not your corrected version. 1/2 times 12 plus 4 equals 10. So 1/2 of 12 is 6, plus 4 is 10. We get the check on that. Okay, so real quickly, visual clues. What do I see? How do I know what to solve it with? So when solving an equation, if you see a addition type problem where you're on the side where the the variable is that you're trying to solve, then you do the opposite to move across that equal sign, which is do the subtraction. If you have a subtraction on the side of the variable, you would do addition. If you have multiplication on the side of the variable, after you've done your addition subtraction step, you would do multiply, opposite is divide. After you've done your addition subtraction step, if you saw division, you would do multiplication. So I keep saying after because this is how it works. When you were only working with equations that had no equal sign, we would simplify and we would use order of operations, PEMDAS, which you're very familiar with. You would work with your parentheses first, what's inside them. Then you would look at any exponents that might be there. Then you would do multiplication or division in the order from left to right. Then you would do your addition or subtraction in order from left to right. So again, multiplication and division is from left to right in order, and the same thing with addition and subtraction. Now we're solving equations. So we have to start with SAD MEP, solving for SAD. This is where there is an equal sign in the equation somewhere. So simplifying is for expressions, no equal sign. Solving is for equations with an equal sign. So we would do either the adding or subtracting, whichever one is appearing, we would do its opposite. So if we saw, again, addition, then to get it across that equal sign, to solve it, we have to do the opposite, which is subtraction. If we see division, we do its opposite, which is multiplication, and vice versa. Then we would deal with any exponents or roots that might be in the equation. So if it was a situation of, say, x squared, you would do the opposite of an exponent, which is its root. If you saw square root of x, you would do its opposite of root, which is the exponent. So these two would be the opposites, kind of like it would be multiplication division. And then it's parentheses, which really means whatever's inside if there were anything inside the exponent or the root. And you would keep repeating this process until you would get your variable by itself. It has to be solved for by itself on one side of the equal sign. Okay, now it's time for some your work practice. I do want you to show your work and tell why, just as if you were just like I did on the example a minute ago. And you're going to enter your answer into Edpuzzle. So what would be the solution to 5x minus 10 equals 20? Okay, so your solution should have been x is equal to 6 and double check your work. So you first should have added the 10 across, then you should have divided by 5 to get your 6. And then we double check it by putting our 6 back into the original equation so that we can find out is 5 times 6 minus 10 equal to 20. Well, 5 times 6 is 30, minus 10 is 20, 20 is 20, so we're good. Okay, the second problem for your turn practice is 1/3 x plus 9 is 21. And what is the solution to this equation? So if you chose x is 36, you're right. And double checking your work, there was addition. So we're going to do subtraction to move it on the other side of the equal sign. And then 1/3, remember we can rewrite 1/3 x, 1/3 times x as being x divided by 3. And then we know because it's division now, it makes it much more clear it's division. We are going to multiply by 3 on both sides. And then we have x is 36. So it is perfectly fine to change 1/3 x into that x divided by 3. So it's easier to see what is going on this side so we can do our opposite on the other side. If you made a mistake and did division here, dividing by 1/3, it would get really messy out and you would probably use a calculator for that. I would recommend just rewriting it. It's much simpler. And then we check it, and here's where you would have caught your error if you'd made a mistake. 1/3 times 36 gives us 12, plus 9 is 21. Okay, so the last part of this note is looking at word problems. Um, I will recommend, and I do expect you to copy down word problems when you have them in your assignments into your notebook. The reason you do that is it's our first read through that word problem. Our second read involves, we use the word cubes as our method of how are we going to solve it. So our first step is to circle numbers and units. So I see the 120, I'm going to circle it, and I don't see any other numbers, so that's done. And then I'm going to underline my question, the entire question, or highlight it, because you want to make a point of having that be your focus and your final step. Then you're going to box in clue words. Clue words are any words that help you to build the equation. So I boxed in one angle and triangle because that's telling me I'm looking at some kind of a situation, and triangles have angles in them, and angles usually are numeric. So that's going to be my boxes. Um, and then I see two angles and the word congruent. Congruent means that they are the same. So I know that I don't know what the size of those angles is, but I know that they're going to be the same, which means that's going to be two of my angles should be x's. And then the next step is to evaluate and eliminate. So evaluate means you may have to draw a picture. And I would recommend drawing a picture, especially with these type of problems. Word problems, generally pictures or tables or graphs, usually help to give you a pictorial representation and helps you to build your equation. So I have a triangle, which I boxed in, and I have one angle that is 120. Then I have two congruent angles, which are x. And that, because I have no means isosceles, I put them at the bottom. You could have drawn this anyway. As long as you had labeled two of your angles x and one of them 120, then that would work. Now, what else do I know about triangles? Well, I know that the sum of all of the triangles is 180. And since they were talking about 120, which is a degree, I know I'm going to have to relate it to 180. So I'm going to write a rough equation of what I think might be what I need to solve. 180 equals 120 plus one of the angles plus the other angle. So I walked around the triangle, adding them all up. Then I clean it up a little bit. 2x plus x is the same as 2x. Now, I also have on here eliminate. Was there anything else in that problem that was extra information I don't need? If I do have that, which I didn't in this one, if I did, I would want to line through it because it's information I don't need. Okay? A lot of times word problems have a lot of extra information or even numbers that have absolutely nothing to do with what you're trying to solve. Okay? Now I'm going to use SADMAP to solve, and then I am showing my work. So we're going to do 180 equals 120 plus 2x. I could have rewritten that as being 180 equals 2x plus 120 if you want to write it that way. Either way, you will still do the first step, which is what's the opposite of plus? Subtract. I subtracted 120 from both sides, and then what's the opposite of times? Well, that's divide. 60 divided by 2 gives me 30. I'm not done until I checked, but I want to check in my original thought, not my process thought. My original thought is the purest form of the equation, and it is the most correct way you could write it. If you try to use your processed one, you might have made an error in that first process that is going to cause your answer to be wrong. So you want to make sure always go back to the original thought. So 180 equals 120 plus 30 plus 30. So is 120 plus 30 plus 30 180? Well, 120 plus 30 is 150 plus 30 is 180. Check. I got them right. So what is now I need to check to see, did my answer match my question? So my answer is 30 degrees. So each of my angles, 30 degrees. Is that what I was asked for? I wanted to write an equation, check, did that. And then I want to find the measure of the congruent angles. Well, both congruent angles were x, and x was 30. So my answer is 30.